Hi everyone, myself Orko Jyotide, and in this video we are going to solve a easy level problem in Leet code. Although it can be a easy level problem of Leet code, but we are going to solve it in three different ways. First of all, we are going to find the most naive or brute force solution. Then we are going to optimize it a little bit to find the better solution. Then from the better we are going to uh, proceed to the most optimal solution it can have. Right, so without further ado, let's start. So what does the question says? The question says minimum number of operations to make elements in an array distinct. So basically you have been given a nums array and you need to ensure that the array have all the elements distinct, like it should not have any duplicates in it. And how you are going to uh, remove the duplicates is that, suppose take the example 1 2 3 4 2 3 3 5 7. So what you are going to check is there any duplicate present in the array? We can see that 2 is present 2 times, 3 is present 3 times, so there are duplicates, right? uh, the array is not distinct. So what we are going to do, we are going to remove the first three elements from the array. Okay, we have removed the first three elements in the array, but still if we consider the remaining array, that is 4 2 3 3 5 7, it still has got duplicates. So what we can do now is we are going to remove the first three elements from the remaining array, that is 4 2 3, and 1 2 3 is already removed, so we are left with 3 5 7. And we are again going to check that uh, is 357 has all the elements distinct. Yes, 357 has all the elements distinct. Then you're done. So what you need to return is how many times you have removed the removed from the array elements, three elements from the beginning. We have removed three times, right? One, two, two times. So the output is 2. Here it is clearly written that in the first operation, the first three elements are removed, resulting in this array. And in the next operation, the next three elements are removed, resulting in this array. So the answer is 2. Now let's check the second example. I'm going to explain all the three examples because examples are very important to actually proceed to the solution. And when there is not much elaborative examples given in the question, you should consider some weird or some examples that is going to hit the edge cases. Considering the constraints, you should look at the constraints as well, because by looking at the constraints and making some weird or some examples that can hit the edge cases is very important. Because if you are going to submit without considering those, you will get a wrong answer in that. And in a competition contest, or in a, what I can say is, in interview or like online assessment test, if you don't consider the edge cases and submit, it actually puts a pretty bad impression upon the people, upon the interviewer or the contest. In a contest, if you do that, there will be some time they will take off from your, from how much time it is left. They can penalty you as 10 minutes time span or 20 minutes, like this. So let's talk about the second example. The second example is that let's consider that a 4 5 4 5 6 4 4, and if I will check it, then 4 occurs 3 times, so duplicates are present, and I need to remove the first 3 elements. For 3 elements removed, but in the next 2 remaining elements I see that duplicates are present, but the is length of the remaining array is 2. So how can we will be able to remove 3 elements from that? So for this condition, in the description it has been clearly mentioned that if the array has fewer than 3 elements, remove all the remaining elements. So we are going to remove, as the array has fewer than 3 elements, we are going to remove the remaining elements, that is 4 and 4, and we are going to get an empty array. And as we all know, it is a common sense that in an empty array there are no duplicates. So we got 2 as output. In the first operation, first 3 elements are removed, resulting in this array. You can read the explanation as well. Therefore the answer is 2. In third example, consider the nums array 6 7 8 9, and if I will consider this, in this example all the elements are distinct. There are no duplicates, so voila, you can directly return 0, no things to do. So that is how you should proceed. So what, how we can think to do this, like to actually solve this question? We can think that let's, as we need to check the constants every time, as the constants are very low, that is only 100, and your operations could go up to 10 to the power 8. Every program should run within 1 second, and 1 second means 10 to the power 8 operations. So as the constants are very small, you can try the brute force or the most naive solution. If I talk about the brute force, what you can do is, okay, every time we are checking that if the array has duplicates or not. So we are checking that. So let's make a function which will check that if the array which we are considering now has duplicates or not. Then our work will be pretty easy. And after considering that, suppose for the first time we will check that for the whole array if duplicates are present, then we will remove the first 3 elements, and then we will again check if duplicates are present within the array we are considering, then we will remove the next 3 elements. Likewise we will perform. So I will go to my submissions and go to the first code, that is I will like see uh, public int mean operations. This is the function to actually count how many operations you are doing to convert the array to a distinct array. So I have taken a variable as c. C is basically represent the count. To count the minimum number of operations, I have written that in the comments so that it will be easy when you read the code. This will help in increasing the readability and rewritability of the code. And why I have taken just c? I should have taken count as the variable naming, then it would be more meaningful. But when you are actually uh, writing the code in a context, writing long variable names will consume your time, as lead code or in OA or in the interview you won't get mm, the extensions. Like you will write C and the whole suggestion of count will come in and you will press in enter and done. So that's why, to save the time, I have written C, and to increase the readability I have written the command. That is why it has been used. And I have taken a low and a high variable. They're representing that what portion of the array are we considering right now. If we haven't take that, then we would have been making an array each of every time we are removing the first three elements. It would be pretty time and space consuming as well, as you need to declare an array of the size n minus 3 then n minus 6, and you need to fill with the elements that the array has original array has to the new array you are creating. So it will be pretty time consuming, and it is just you don't need that, right? So for that reason, uh, what I have done, I have taken a low and a high variable which are like the pointers that are pointing to how much portion of the array are we considering right now. Then what we are doing, we are passing, we are calling the function is duplicate present. uh, right now consider it as a black box. You don't have to think for it right now. And this thing passes the nums array and the low and the high, which will show that how much portion we are considering right now. And for the first time, if the operation is done, we are going to increase the counter by 1, and we are going to increase the low by 3. Why we are increasing the low by 3 is that we are eliminating the first three elements and then again checking is duplicate present. Then if the duplicates are present, then again counter by 1, because we are again we are increasing the number of operations we are doing on the original array, and we are again increasing the lower variable which denotes the starting of our consideration array by 3, and at last we are returning C. So now I'm going to uh, present the is duplicate present mm, function. So I have declared it private because by declare your user should not get the function, right? Your user doesn't need it. You are just treating the function as a helper one to get your work done. So your user don't need the function to do anything. That's why I have written private. So you are just accessing the function. Now what I have done is I am iterating the ith loop, just like you have seen in some bubble shot technique. I am fixing I, and then I am traversing the remaining array forward to I, like j is equals to I plus 1, and I am traversing the whole array that is next to I. And as soon as I find my ith element and jth element becomes equal, I will return true, that yes, duplicates are present in the array. And if I don't find anything equal, then return false, no, duplicates are not present. Done. But uh, the thing is that the time complexity of this code is like how many times is duplicate present is gonna work in the worst case. It will work if we consider n as the length of the original array, then For the worst case time complexity, it will work for about n by 3, right? And each time it work, it calls each duplicate present, and the time complexity of each duplicate present is um, in the order of n square. So this is the time complexity is of n cube, big of n cube. So can we do anything better than this? Can we write some code which will be better than this time complexity? Yeah, we can do. By thinking over this thing, I've got another code that is like, now what we can do is, for checking is duplicate elements are present in the array we are considering or not, we can take a frequency array. And what will be the length of the frequency array? As we have seen the constants that the numbers that are present in the array is within the range of from 1 to 100. So we are taking the frequency array as size 101, and at first filling every box of the array as 0, right? Arrays.fill function will do that for us. Now what we are doing, we are going to the index of each of the frequency array which have the number in the array, and we are incrementing the value by 1. Likewise, we are making the frequency array. Next, what we are going to do is, for the first time, as I have already told, that C is for counter, L is for low, and H is for high. Is duplicate present is we are passing the frequency array and the low and the high. Now we are going to work on the frequency array. What we are going to do is, if we are for the first time, if duplicates are present, then we are incrementing the count as 1, and we need to decrement, like we are removing the first three elements, right? So here you can see I'm running a loop from 0 to 3, and in this thing I'm removing, I'm decrementing the frequency of what elements I'm removing, and likewise, and then I'm incrementing the L. And what is duplicates present is doing now is just checking that if any frequency have greater than 1, that means duplicates are present. If greater than 1, then returns true. If not, return false. It's quite simple. So here, what is the, let's consider the time complexity, because we are actually using some extra space to making the frequency array. All the space of the frequency array is big of 101, so that's a constant. Big of 1 we can consider, but it is because the constants are less. If the constant will be more, then it would increase. So by compromising the space, are we been able to decreasing the time complexity? Because if we can't, then it is no use, right? So each duplicate present is now operating on a big O of 101, like the length of the frequency array, which is 101. So it is operating on big O of 101. And what I can say is, uh, so if I consider the length of the frequency array to be big of to be length of m, then the time complexity would be, for every time it is duplicate present is running off big of m, and this is 3 times. So m into 3 into how many times this while loop is running at the worst case is n by 3. N is the length of the nums array. So n by 3 into 3 into m. So it will be m into n, right? Earlier we are doing it for n cube, and it is m into m, and also m is a constant, so it is a big of n. But uh, if m is not constant, then this would not work. Then we will be thinking something different. And what is that? Let's check that code. And for the next code, we are that is of big of m into n, and now we will be solving it at a order of only big of uh, n, and the space complexity will also be less. It will be the length of the nums array at max. So I'll be making a frequency map. I'll be using hash map for the task. The map will have a key as integer value and key value pair as integer and integer. And first of all, I am making the frequency array. That is, I'm traversing the whole nums array, and I'm picking the current element. If the current element is not present in the hash map, then we are putting the current element and marking its frequency as 1. Else, if it is already there, then we are putting the current element as we're getting its previous frequency and incrementing it by 1. So that's how I am making the frequency map. So now, just as the same, I'm using count low high, and I'm calling each duplicate present, and I'm running a for loop for from 0 to 3 for removing the first three elements that from the array that I have considered. And how I'm going to remove the first three elements is I am just removing the first three elements by reducing its frequency by 1, and if some frequency becomes 0, then we are removing it from the hash map, and later incrementing L by 3. And now check how is duplicate present is working. Is duplicate present is not iterating anywhere. I'm just calculating how much is the size of the array that I have considered now, and what is my frequency size. If every element occurs once in the frequency map, then the size would be equal to as the length of the array, and then return false that no duplicates are not present, else returns true. So now what we are checking is that as soon as the frequency size is equals to the length of the array we are considering, then return false that no duplicates are present, else return true that yes duplicates are present. But if I for the first time I haven't written this part of the code, or snippet, that is or frequency dot size this condition, and for this I'm getting an error. That what is the error? I haven't considered the edge case, that the if like the array becomes empty, or yeah, the array becomes empty, then also duplicates are not present, and I should return false, but I haven't considered that condition, and that's why I'm getting error. And from here we are getting a lesson that you should always consider the edge cases and run your code, dry run your code with 2 to 3 complex examples, so that your code is error proof, right? And now what we are going to do is how we can check that okay, our array has become empty. As soon as our low will become greater than high, then our array is empty. And when our array is empty, our frequency size map also should be empty. And that's why we're returning false. That this is this condition, which is in blue right now, is checking that if the array is empty and the frequency size is 0, then there is no duplicate present at all by common sense, so we are returning false. So that is the what I can say code. And now let's consider the space and the time complexity of this code. So here we are using a hash map, right? So the space complexity of this is at Voigt's condition is big of n, where n is the l- length of the array at Voigt's, right? If all the elements are distinct, then it would be big of n. And we are compromising the space. What reduction in time complexity we're getting for that? It will be like for this part, it is big of n length, big of n for making the frequency map. And then at max we will be running this while loop for n by 3, and for this for loop n by 3 into 3, and each duplicate present is actually running at a constant time big of 1, because it has nothing but two conditions to check. So we have got a pretty good time complexity as big of n. We have ordered, we have solved it in a linear time complexity as big of n, and this is the most optimum solution that I can think of. And the codes are in Java. You can check this code. This might help you. Any suggestions, put down in the comment section. And done. We have solved a easy level question, but we have uh, considered each and every case. We have uh, trained our brain to how to reach to the most optimal solution, because the brute force can also be accepted as the constraints are pretty less. But we actually thought if the constraints were big enough, then how we can optimize our code. So this is done, and thank you for watching the video. Bye bye.